Welcome back to the session. We'll now look at this problem. Question number 2. Design an inverting amplifier with a closed loop gain of 80. So I'll just note down closed loop gain. It is AF is 80 and an input impedance of 1.5k. So the input impedance is nothing but the input impedance is input voltage by input current. So input voltage input current is nothing but Ri. The input impedance of this amplifier is 1.5k. These two things are given actually. Now the question is, the first part is design an inverting amplifier with a closed loop gain of 18 input impedance of 1.5. So I know that AF is equal to minus RF by RI, which is equal to minus 80. RI is given, so you can find RF. So the value of RF, if you solve it, is nothing but 120 kilo. So AF is given as 80. If you want to find RF, 80 into 1.5, 80 into 1.5, right? Yeah. It is 120 kilo. Yeah. Now we look at the second part. The second part says that if the op-amp has an open loop gain of 2500, so the A part is done. Now we'll go to the B part. If the op-amp has an open loop gain of 2500, so I'll take open loop gain as A. It is not infinity, it is 2500. Find the closed loop gain of the amplifier. So when the open loop gain is not infinity, we know that the closed loop gain formula is nothing but minus Rf by Ri divided by 1 plus Rf by Ri divided by A. You can just look back the derivation what we have done before. Minus Rf by Ri divided by 1 plus Rf by Ri divided by A. Right. So here now we have minus Rf by Ri as 80. Yeah. Now the question is find the closed loop gain of the amplifier. You should find AF if A is this value. So you can find AF as this is equal to minus Rf by Ri is 80 divided by 1 plus Rf by Ri is 80. So it is 81 divided by 2500. If you solve this, you will get this as minus 77.4. So for an infinite, when the open loop gain is infinity, you got AF as 80. Now if the open loop gain is reduced to 2500, if it is a finite open loop gain, you are getting closed loop gain of 77.4. Now if you look at the third part of the question, C, what it says is design the value of resistor 1 can place in parallel with R1. So here R1 is nothing but Ri in our case. To restore the closed loop gain to its nominal value. The nominal value of closed loop gain is what it is given in the question, that is 80. Now what happened here is because of the finite open loop gain, the gain has decreased from 80 to 77.4. Now in order to restore the closed loop gain to 80, what they are asking is you should find the resistor value which I can place in parallel to Ri. So some resistor I can place in parallel to Ri, so Ri parallel to some new resistor. I don't know the value of that, so I'll call this as Ri dash. Now the thing is to find that the value of resistor R which I can place in parallel to Ri to restore the closed loop gain to the same value. So what I can do here is, what I wanted is finally I want the closed loop gain of 80 only. So 80 should be equal to minus Rf by, it should now it is not Ri, it should be some Ri dash, new resistor, because I should add a resistor in parallel to Ri in order to make the gain as minus 80. So divided by 1 plus again 1 plus Rf by Ri dash divided by A. So here I think you may get a doubt because the question says that I need to find, you are asked to place a new resistor in parallel to Ri. So I'm calling the new resistor as R and the total resistance as Ri dash. So that what happened to the nominal gain? It reduced from 80 to 77.4. We need to restore the gain back. So that the closed loop gain should be equal to 80 by placing a resistor in parallel to Ri. So you are asked to find the value of that resistance. So the other things remain same. Again, your A is in this case 2500 only. It is not infinite. So you can just substitute all these things here. So 80 is equal to, yeah, again it is minus 80. So minus minus will get cancelled. So I need to consider the minus only. So RF by Ri dash divided by 1 plus RF by Ri dash divided by A. In this, A is 2500. You can solve this and you can get the value of RF by Ri dash. If I do, I'll get us some 82.7. And from that, you can find the value of Ri dash. It is 1.45 kilo ohm. The value of Ri dash is 1.45 kilo ohm. Now, so Ri into R divided by Ri plus R is equal to 1.45 kilo ohm. So you know the value of Ri. So by substituting the value of Ri is, I think it is 1.5k. Yeah, it is 1.5k. By substituting that, you'll get the value of R here, and that R is nothing but 43.5 kilo. So in order to restore the gain back to 80, you should add a resistance of value 43.5k in parallel to the already existing resistance Ra, which is 1.5k. That's all about this question. Similarly, you can try question number 3. An inverting amplifier using an op-amp with open loop gain of A has a closed loop gain of G. The minimum value, find the minimum value the gain A must have for a gain error of 0.2%, 0.3%, 0.2%, 3% and 5%, it seems. So you can do that, and your final answer, you will get it as minimum value the gain A must have in terms of G. So A is equal to, you'll get A as 19 minus 20 times G. Our G is a closed loop gain. Okay. That is for the last case, 0.2%. Similarly, you can try that. You just try out this question. Okay. Yeah, so that's all about the second question. I'll stop this lecture here. We'll continue in next lecture. Thank you.